any two forces, okay, let's say for example, this is 8 newtons, for example, and let's say this is 4 newtons, for example. Now what you can do is to use a certain scale, all right? Let's say for example, 1 cm is to 1 newton, okay? So in other words, right, 8 newtons will be 8 cm, and 4 newtons will be 4 cm. Right? There are two ways to do this, okay? One way is to use the tip to tail method. All right? Tip to tail method, what do you mean by that? I have to shift, okay, I shift this vector, okay, such that the tail of it goes to the tip of the other vector, all right? Okay? Now bear in mind that this is drawn to scale. For me, I didn't draw to scale because of time. I'm just rushing this. All right, I want to get to the more important part. So here, it is drawn to scale. That means that the long line is 8 cm and the short line is 4 cm. All right? And I've shifted, okay, just now what I did was I shifted that arrow such that the tail of the 8 newton is touching the tip of the 4 newton. All right? So the resultant, okay, the resultant force will be from the tail of the 4 newton to the tip of the 8 newton force. All right? And that will give you the resultant force. Give me a minute, Okay, so the resultant force, okay, you just measure and you just use the same scale. So you measure using your ruler, all right? Using the scale that you have determined, you can find the resultant force. Okay, so this is what we call the tip. The tip to tail method. Okay. This is the tip to tail method, all right? Any question? Yes?
Is the resultant force same as net force?
Yes, resultant force is the same as net force. Okay? Resultant force. So I told you before, right? If let's say the two forces are on the same line, it's very easy, right? If one person pulls me to the right with 8 newtons, another person pulls me to the left with 4 newtons, the resultant is 8 minus 4, 4 newtons to the right. Agree? Now, the problem is when the two forces or the two vectors are not directly on the same line. Okay? In this case, they are right angles, so it's still easy because it's more or less what we call a rectangle. You can just find by Pythagoras theorem, you can actually theoretically calculate it by finding, let's say, the resultant force, I call it F net. F net squared is equal to 8 squared plus 4 squared, and then you find square root of 8 squared plus 4 squared, right? Now this is only for two vectors that are at right angles to each other, okay? When it's not at right angles, you can't do that, right? Okay, but before I get to the other more difficult questions, right, let me settle the rectangle first, because the rectangle is the easiest, all right? Yes. Okay, then the other method is what we call the parallelogram method, all right? The parallelogram method. Okay, the parallelogram method. Okay, the parallelogram method. Now, the parallelogram method basically, right, back to our original question. All right, let's say I have 8 cm over here. Actually, should I draw it using paper? I think I'll draw it using paper because that's what you will be doing. So I'd rather do it on paper to show you exactly how it's done on paper. Okay, let me try and get this right. Okay, let me try and get this right. Okay, so if it's the 8 and 4 newtons again, okay, I'm sitting in a weird position. Let me see how should I do this. You lost focus, Sorry? Okay, this is the parallelogram method. I'm trying to draw it on paper. So my original scale was 1:1 Newton. 1 cm is to 1 Newton. Okay, so I'm going to measure 8 cm. Okay, 8 cm. I have a bit of parallax error here, so it may not be so accurate. I'm just trying my best. Okay, 8 cm, right? So 8 newtons, 8 cm. Okay, using 1 cm is to 1 newton, right? So this is the original 8 newton vector. And then I now have to use a protractor, okay, to measure 90 degrees. And I have my 4 Newton force. I'm going to use 1 to 5 cm instead of 0 to 4 because I want to reach that dot over there. Right, so it will be 1 to 5 cm. Oops, over here. I make a mark. Okay, so now the parallelogram method, basically you need to construct a parallelogram. Now this is not a parallelogram, it's a rectangle because it so happened that the angle here is 90 degrees. If it's not 90 degrees, then you have to construct a parallelogram. Alright, so the rectangle is a specific case of a parallelogram, right, where the angle is 90 degrees. Okay, so what I need to do is to construct a perfect rectangle, right? For me it's a bit difficult. You all try to do it accurately, Okay, get a piece of foolscap and draw this, please. Alright, get a piece of foolscap and draw this as accurately as you can. Okay, draw this as accurately as you can. The accuracy matters a lot. Okay, the accuracy matters a lot. The WA, we will be probably marking you with an accuracy of let's say plus or minus 2 mm. Okay. Right, so now to find the resultant force, okay, resultant force will be the diagonal of this rectangle. Okay, the diagonal will be the resultant force. Alright, okay, so when I measure it, I got Okay, so when I measure this, I got 8.9 cm, right? So the resultant force, F net means net force. Net force means resultant force. Okay, net force means resultant force, and it is 8.9 cm, so it's 8.9 newtons. I'm using a very simple scale here. Later when you all try, it will be different because I will give you something that is a little bit more challenging. Okay, can somebody press the calculator and calculate using Pythagoras theorem whether our answer is correct?
Yes, it is
8.94, right? Okay, so we are very, very accurate. Alright, okay. Let me give you another question. Okay, let's say we have two forces, alright, at, okay, let's say there are two tugboats. Okay, let me write the question down. Okay, let's say there are two tugboats. Okay, pulling on a boat, okay, with a force of, let's say, 600 kilonewtons, right, each, okay, at 30 degrees to each other. To each other, okay? So, all right. So two tugboats pulling on a boat with a force of 600 kilonewtons each at 30 degrees to each other. Okay, find the resultant force. Okay, now I'm using forces because it's easier for us to think about forces. But it can be any other vector. For example, it can be a boat going due east, and then there's a water current that is pushing it southeast at a certain speed. Then I ask you to find the resultant velocity, all right? That can also happen. So it can be any vector. Basically, it can be any two vectors added together, okay? So now, how do we do this one? You all know how to do? Two tugboats pulling on a boat with force of 600 kilonewton each at 30 degrees to each other. All right. So first of all, determine a suitable scale. Determine a suitable scale. All right. So what's a suitable scale? I think 1 is to 100 kilonewton will be suitable, right? Okay. Yeah, that's what we are doing. We are drawing a parallelogram. Okay, so here you need to construct a parallelogram. Alright? You all need me to show you how to do it. Can you all try yourself? Construct a parallelogram. So here a suitable scale will be 1 cm is to 100 kilonewtons, right? So 600 kilonewtons will be 6 cm, right? Can you all try it yourself? Come on. You can use two ways, I told you, right? You can use the tip to tail method, in which case you get a triangle. How to use the tip to tail method? Tip to tail method is I shift this vector over to here, right? Then I draw the line across. That is my resultant. Okay? Then if I use parallelogram method, then obviously I need to construct this line over here and this line over here, and then I draw the diagonal, right? Which is effectively the same thing. Actually, it's the same thing, right? Whether you use the tip to tail method or parallelogram method, actually in the end it's the same thing.
I should have put my thing out in the
I don't have a ruler.
I don't know. I think I feel like I don't know.
You know that you go to school doesn't afford much because obviously
So what I do is buy
Hey guys, are y'all done? What's your answer?
I think first. 1,100. That's a
Okay, if I were to mark my own work, I will minus 1 mark for accuracy. Okay, because I should get 1,160 kilonewtons plus or minus 20 newtons. So if any one of you manage to get between 1140 to 1140 to 1180, very good. Okay? Anybody got between 1140 to 1180? Very good, very good. Excellent. Okay, good job. Yes. 1180. Ah, very good. 1160 is the correct answer. Yes. Okay, he has a question here. He says, why don't we use two cylindrical figures? Okay, actually, normally yes. But in this case, right, because your scale is 1 cm is to 100 newtons, right, that means that your increments is by 100. Alright? So minimally, because you need to measure to the precision of your ruler, which is 1 mm. Right? So actually you can go up to 1/10 of 100, which is 10 kilonewtons. You hear what I say now? That means you can be as accurate as to the nearest 10 kilonewtons. So when the exam question, the marker, right? When we write, I need to write on the paper here so that the recording is done. Okay, if the mark scheme, right? Mark scheme will show, all right, 1160 kilonewtons plus or minus 20 kilonewtons. Okay, because it will be 11.6 cm plus or minus 0.2 cm. Okay, that's your mark scheme. The mark scheme will show that. All right. So that's why accuracy is very important for scale drawings like this. Okay. So any questions? If you were to draw, the tip to tail method, you all know how to do it? The tip to tail method basically, okay, I need to shift, can you look up at the screen? The tip to tail method, I need to shift this 600 kilonewton force, right? I shift this over here such that the tail of the vector is touching the tip of the other vector. Then I draw the line across. Effectively, you get the same thing. It's just that you don't have the triangle below. That means it is a triangle instead of a parallelogram. But effectively, it's the same thing, right? So, can I ask how do you all construct this? Do you all use this 150 degrees here? That's one way to do it, all right? You remember that for parallelogram, the two angles facing each other must add up to 180 degrees, right? So you can determine that this is 180 degrees, 150 degrees, right? And do this, okay? Are there any other methods? Did anybody use any other method? Okay, you all get the idea? Okay, ready? Do you need another example? Don't need, you know how to do already, Okay, so basically, okay, how do we express our answers? Okay, this one I haven't taught you yet. Yes, question? If the two, okay, his question, sorry, your name again? Maverick's question, right? Say that if they are basically the same thing, tip to tail method and parallelogram method are essentially the same thing. Why do you need to have the parallelogram? Just use the tip to tail method. Now, if you do enough questions, you realize that for some questions, it is easier to do one way. Okay, than the other. All right. For me, I do prefer parallelogram method because if you have to construct a parallelogram, you can check. You can check that the two lines are parallel. These two lines are parallel. You can check that it's correct. You know what I'm saying, right? You know that these two lines are parallel. These two lines are parallel. Then you know that it's correct. Just now when I was measuring, I knew I was wrong already. Because when I was measuring, I said, how come this one is not 6 cm? It's not exactly 6 cm. That means I'm wrong already. I know already. So when you do parallelogram method, you can actually check visually whether it's accurate or not. Okay, how to write answers for this, right? Okay. So after I've drawn the diagram, how do I write the answer? Okay, ignore this mark scheme thing. This is just for your information. How will you write the answer? Okay, you say that the resultant force is, for me it's 1,200, but it's not very correct. Okay, for me I write 1,200 newtons. For you will be 1,180 or 1,160 kilonewtons. Whatever lah. Okay, at how many degrees? Okay, so you got to measure. Okay, here is, for me is 10. Okay, for me is about between 10 to 11 degrees, nearer to 11. So I say at 11 degrees, at 11 degrees to the 600 kilonewton force. Okay, so your answer must have the resultant force, the magnitude of the resultant force, and the angle. Alright? Okay? To what? To the whichever force. Okay? So if let's say I want to know what's the exact answer, look at here, right? Wow, got add on. Okay, it's 15 degrees. I'm way off. 15 degrees. So my answer is actually quite wrong. It should be around 15 degrees. Okay? Should be around 15 degrees. Alright? My answer is off. Okay, so it should be 11 degrees or 15 degrees to the 600 Newton force. Now in this question, right, the two forces are equal, so it makes your life easier. But very often, the two forces are not the same. Okay? So when you write the final statement, right, for example, if it's not 600 and 600, it's 600 and 800, then you need to be very clear. It is how many degrees to which force? Is it the 800 kilonewton force or the 600 kilonewton force? Do you know what I'm saying? Okay? Does it matter which one you say? It doesn't matter. So for example, if I say how many degrees to the 800 kilonewton force, another person will say the other angle to the 600 kilonewton force, it will be different. That means the answer for two people may be different because you're taking reference from different forces.